All right. I see somebody's turned up for our review session. I did see that number go up to two briefly. Um, yeah, so I'm just going to hang out until more of you are here and start to share your questions. But basically, I'm going to be here hanging out for about the next hour or so. Um, to answer any questions that you might have ahead of your final exam tomorrow. So I have made the exam, I've sent that over to your teachers. And in this review session, I'm going to go through the structure of that exam. So for those of you who turn up, you're going to know exactly what to expect in terms of the topics that are covered. Obviously, I'm not going to show you the actual questions, but I will show you the topics, or I will tell you the topics that are going to be covered on the exam. And I wrote out all the topics on my whiteboard here. So I'll put this here for a sec for those of you that are here already. So those are all the topics that are going to be covered on the exam. So it's not too much. It is a little bit if this is the first video on the channel that you've ever watched, which should not be the case for any of my students, of course, then yeah, this might be a lot. But for those of you that are in my class and that have been following along with these concepts throughout the term, there shouldn't really be any surprises here. I know we just got into perimeter and area down here. But aside from that, there shouldn't be too much that uh, looks new or surprising. So I'll leave this here for a sec, but all the information that you need is also in the chat. So if you've missed this section of the review, whenever you drop in, you should be able to see all this information in the chat as well. Hello, I see we've got somebody in the comments already. Hello, hello. Hope you guys are doing well. I hope you're not feeling too stressed about the exam. How are we feeling? Thumbs up, thumbs down. What are we thinking? 50-50, a little down. Okay. All right. So, yeah. So I was thinking what I can do for you guys to start. Of course, if you have specific questions or specific topics that you would like me to go over, I'll be more than happy to try and come up with some questions. But what I can also do is I can go through question by question. Question one on the exam is going to be this. Question two on the exam is going to be this. These are the word problems. These are the things you need to know to be able to do the word problems. Would you guys like that? Thumbs up, thumbs down if you'd like me to go through that sort of whole breakdown of the exam and what's going to be on it. Yes. All right, cool. I've got a yes. So, okay. So what I'm going to do is I will say it and I'll also write it in the chat for anybody who drops in a little bit later. So, question one is all about fractions. So that's going to be addition, subtraction, multiplication, and division of fractions. And there's 8 parts to it. So it's 2 addition problems, 2 subtraction problems, 2 multiplication problems, and 2 division problems. So that's 8 in total. So that's going to be fractions. Easy. Awesome. Question 2 is converting between improper fractions. I shouldn't write that in all caps. Is converting between improper fractions and mixed numbers. And there's just 2, one of each. So one going from improper to mixed and one going from mixed to improper. And that's all there is to that. So not too much there. Hello, hello. So I'm just, for anybody who's just dropping in now, I'm just going through the structure of the exam, what the topics are, and what the different questions are going to be covering. So, like, question one is fractions, question two is converting between improper fractions and mixed numbers. Question 3 is all about decimals. So that's going to be addition, subtraction, multiplication, and division of decimals. So if you know how to do that, then that's the first 3 questions of the exam, and that's the first 2 pages of the exam is questions 1, 2, and 3. Okay, so I can go through an example of dividing decimals once I've finished going through this, uh, this whole structure of the exam. Okay, yeah. So we'll do an example of dividing decimals in a few minutes. Question 4 is all about exponents. So you have to calculate a value using exponent rules. So that's stuff that's like you've got 2 to the power 3 multiplied by 2 to the power 4. And there's a way to kind of, get a little shortcut out of that. That actually wasn't the best example for it, but you know what I mean. Yeah, so we're going to be using exponent rules to solve those questions. Um, so that's going to be things like the product rule, quotient rule, the power rule, etc. And there's 4 questions there, so um, you should be comfortable with those 3 rules for sure. Question 5 is algebra, and that's going to be algebra problems with one variable. So that's going to be like solve for x. Um, based on the equation that's given to you. So there'll be just an x. There might be a couple of x's, but it's not going to be like x's and y's. It's just going to be an x or two, and you just have to figure out what. Yeah, the simple algebra. Hello, hello. Question 6 is also algebra, but this is problems with 2 variables. So that's solve for x and y. But because these problems are harder, the 2 problem ones, or sorry, not the 2 problem, the 2 variable ones, because those are harder, there's only 2 of them. So for the 1 variable problems where you just have to solve for x, there's 4 of them. And the problems with 2 variables, there's 2 of them. They're worth a little bit more marks each, but there's only 2 of them. You found problems with 2 variables easier. Okay. Question 7 is about triangles. So you will be given some diagrams of triangles, and you have to decide whether each triangle is equilateral, isosceles, or scalene. Oh, it's Hendrik. Okay, I would see. It's weird for me because I see your names on like when I get your test marks and stuff, I've got all your actual names, and then for the review sessions, for most of you, I have no idea who's who, with one exception. But so it's fun for me. Um, but yeah, so question 7 is so basically you'll be given like a picture of a triangle. So I can even give you an example. So I'm gonna erase this. If you missed this, this is back near the beginning of the live stream, so you can catch that a little bit later. But so the idea with this question 7 is you'll be given a diagram. So you'll be given something like this. So you'll have like a triangle like that, and you'll be asked is this an equilateral triangle, an isosceles triangle, or a scalene triangle? So nothing too difficult. There's four of those, so there's four different triangles. It might be equilateral, isosceles, or scalene. You have to decide which one. Awesome. The one I just did in the example, that was an isosceles triangle. Question 8 is also triangles, but this time you will be given some diagrams again. Um, and you will have to decide. This time it's not going to be equilateral, isosceles, or scalene. This time it's going to be based on the types of angles that you have. So you have to decide whether each triangle is acute, right, or obtuse. So basically with that, if you know, so hang on, let me show you. Diagram here. So here are, yeah, that's it. So acute angles are the small ones, obtuse angles are the big ones, right angles are the ones right in between, the kinds of angles you find in squares and rectangles. So if you know your types of angles, then if you have a triangle that's got one right angle in it, it's a right triangle. So that would be one that looks like this, would be a right triangle because it's got a right angle in it. Now, if you've got a triangle that's got one obtuse angle, so something like this, then that's going to be an obtuse triangle. So if you've got an obtuse angle in your triangle, it's going to be an obtuse triangle. If you've got a right angle in your triangle, it's going to be a right triangle. And if you don't have any right or obtuse angles and they're all acute angles, then you have an acute triangle. And that's all there is to it. That's all you need to know for that question. Yeah. So question so the yeah, so the question we're talking about right now, question 8, you have to decide whether each triangle is acute, right, or obtuse. On the question before that, you have to decide whether the triangle is isosceles, scalene, or equilateral. So that's the one where it matters whether your side lengths on your triangle are the same for two sides or whether they're different lengths on different sides, right? Like that. Or if you've got, let me just make an equilateral triangle here. Right. So the question before this one, you have to decide between equilateral, isosceles, and scalene. So that's equilateral because all the sides are the same length, isosceles because two of the sides are the same length, and scalene because every side is a different length. So that's one of the questions. And then the next question is this acute, right, and obtuse thing. But that's written in the question. So when I give you the question, it's like, here are the diagrams. Tell me equilateral, isosceles, or scalene. And I even tell you, like, count whether the sides are equal. So you don't have to memorize that. I tell you, I'll even give you the wording of the question. So question 7, where we care about the equal sides, it says, based on the number of equal sides, describe each triangle as either equilateral, isosceles, or scalene. And then you've got some diagrams and you can write in your answer. And then the next question says, based on the types of angles, describe each triangle as either acute, right, or obtuse. So that's it. And then you've got some diagrams. So there's 4 triangles for each of those 2 questions. And then we've got question 9. is quadrilaterals. So, yes, so the exam is 6 pages and it's 12 questions. So we got a few questions left. It is very long. There is a chance that some of you, if not most or all of you, will have to sit in again to finish the exam. I heard that Mr. Austin is going to be doing a resit for um, for the other math class for their exam. So that might be an extra period for you guys to work on yours. But yeah, so we've gone through 8 of the questions. Question 9 is also this diagram thing. Um, so this is on quadrilaterals. Question 9 is quadrilaterals. So classify quadrilaterals based on their properties. So things like side lengths, um, number of equal angles, right angles, etc. So all the different things that we talked about, like what makes a square, what makes a parallelogram a parallelogram. You're going to have 8 quadrilaterals, and you have to decide: is this a square? Is it a rhombus? Is it a parallelogram? Is it a rectangle? What am I looking at here? So that's what question 9 is. There's 8 diagrams for that one. Question 10. So the last 3 questions, questions 10, 11, 12, are all word problems. So question 10 is a word problem where you have to deal with percentages. So you have to calculate the total amount you pay um, with with a tax. So that's something like, you buy a drink and there's a 15% sales tax. The drink cost $5 before tax. If you have to pay the 15% tax on top of it, how much does the drink cost? So you have to be able to use percentages. Basically, you have to be able to turn a percentage into a decimal so that you can do the multiplication. So that's question 10. It's a word problem, so you have to pull the information out of it. Question 11 is perimeter and area. It's also a word problem. So for this one, you have to calculate the perimeter and the area of the basketball court, the school's basketball court. Now, I'm not going to send you outside to go and measure the basketball court, so I kind of made up numbers for how long and how wide the court is. Um, so you have to calculate the perimeter and area of the basketball court. And question 12 is also a word problem, and this is two variable word problem with two variables. So that's one where one of you who's here in the review session right now by name, you're being featured in the exam. One of you has decided to sell some prom 2024 t-shirts and hats before Friday. You charge this many dollars for a t-shirt, that many dollars for a hat. If you sold 25 of them, 25 things in total, and you made this much money, how many of each one did you did you sell? So that's what that question is. Obviously, I'm not giving you the actual number so that you can't go and do that. But if it's something like, yeah, only areas of rectangles and squares, that's all you need. Um, but yeah, so those are the 12 questions. So it is a bit long, 6 pages. Now, it's not exactly 6 pages because the first page of the exam is like a bunch of instructions. So only a little piece of question one shows up on the first page. So it's basically 5 pages and a little bit. Um, and also keep in mind, I I almost want to show you guys the exam because you'll freak out a little bit less. But I won't show you the actual exam, but I will tell you. So the first page is mostly like instructions and me telling you these are the topics that are going to be covered on the exam and whatever. But also the questions that are like, Here are your diagrams of the triangles. Here are your diagrams of the quadrilaterals. Those diagrams, those pictures take up a lot of space. So 2 pages of this exam is literally just pictures of triangles, pictures of quadrilaterals. So it is a 6 page exam. It is 12 questions. There are 3 word problems, sure. But 2 of the pages are just diagrams and one of the pages is just instructions. So it's really like 4 pages. Like it's not that bad, right? I won't show you the actual exam basically because I don't want any of you taking like a screenshot and then solving the actual exam questions with a sibling's help or with the internet's help, especially with ChatGPT and stuff now. But I think I've told you guys enough information that you have a fighting chance with this exam, right? I've told you the types of questions that you're going to get. You're going to get addition and subtraction of fractions, multiplication and division of fractions, all of that in question one, improper and mixed fractions in question two, and so on. So you've got all of that. Now, I did see yeah, I know some of you are not happy with the percentages. I did see a little while earlier, a couple of you said that you um, forgot how to divide decimals. So what I can do is I can go through a quick exam of a quick example of that. Oh, you guys have your history exam tomorrow? Oh, you guys can do it. It's pretty much, I'm going to be honest, for not for the entire test, but for a pretty solid chunk of the test, I literally just pulled the questions off your previous 2 unit tests and changed the numbers. So there's really nothing new going on up until we hit the geometry section. Everything else is stuff from before. I copied the format, I copied the wording, I copied the marking scheme, and I just changed the numbers. So if you could add fractions on the last test, you're fine. You guys have history, this, and French tomorrow? That's a that's a lot. Yeesh. All right. Okay, well let's take this one step at a time and we'll do a division problem with fractions or with decimals. Baguette. Perfect. Yeah, we're all set. Yeah. You know, I should this should inspire me. This conversation that you guys are having in the chat right now should inspire me to practice my French because it would really help me at my job if I could speak some more French than I can, which is almost none. Um, but okay, let's do something like this example here. So this is 12.5 divided by 5. I've just written it as a long division problem. So basically the idea here is you can pretty much ignore that this decimal point exists. All you have to do is remember that in your final answer, you've got to have a decimal point up here where you write your answer that lines up perfectly with this decimal point right here. So I'm just going to plop a decimal point up there before we've even done any work. And now we just do the division problem as if the decimal point isn't even there. So we do regular long division. How many times does 5 go into 1? It doesn't, so we ignore that. How many times does 5 go into 12? It goes into 12 twice. 5 times 2 is 10, so we bring that down here. Subtract that. 12 minus 10 is 2. We pull down this 5. We ignore the decimal point. We literally don't care about the decimal point aside from doing that little thing up there, putting it into our final answer, into our quotient. So we pull this 5 down. How many times does 5 go into 25? That's 5 times. 5 times 5 is 25, so you subtract 25, and you're left with a remainder of 0. And there you go. You've got your answer of 2.5 up at the top there. So is the question on the exam going to be like that or way more tricky? So the problems for division of decimals are about this hard. So there's one that's about as easy as this one, and then there's one that it's the same thing. It's just a little bit of a it's just a couple bigger numbers. So instead of 5, it could be like 12, let's say. So just a little bit of a bigger number here, a little bit of a bigger number there, but it's the same idea. Can you also do multiplication of fractions? Absolutely. So suppose we have, and then division of fractions? Absolutely. So suppose we have something like this. For our multiplication of fractions, suppose we've got something like 4 over 5 times 6 over 7. Don't overthink it. Multiplying fractions, very, very straightforward. You take your two numerators, the two numbers sitting on top, multiply them together. That's your new numerator in your answer. So if I do that, 4 times 6 is 24. So that sits up on top. On the bottom, 5 times 7, 35. That sits right there. And that's your answer. That's all there is to it. Depending on the question, you might have to reduce your fraction. So if it was like, if your answer came out to 12 over 24, you got to do the extra step and say, oh, well, 12 over 24 is 1/2. So that's, I'm going to write it like that. Oh, decimals. Yeah, yeah, yeah. I can do that too. Just, I'm not sure if anybody needs it for division of fractions, but I'll do that as well real quick. So same problem. If we were to put a division sign there instead, so 4 over 5 divided by 6 over 7, all you do is you take the second fraction here, you flip it upside down. So instead of 6 over 7, it becomes 7 over 6. You keep the first fraction exactly the same. And once you've flipped the second fraction upside down, you change the division sign into a multiplication sign, and it's just a multiplication problem at that point. So 4 times 7, 5 times 6, and then you might have to reduce a little bit, and that would be your answer. Now for decimals, multiplying and dividing decimals. So we just did an example of dividing with decimals. We're now going to do an example of multiplying with decimals. How do you add fractions? So we'll do that next. So division or multiplication with decimals. So if you have like, if you have something like this, 21.7 times 1.4. So basically you do this as though it's a long multiplication problem without any decimals. And then all you have to do is when you get to your final answer, you have to make sure that the number of digits after the decimal point in your answer is the same as the number of digits after the decimal point up here. So we've got 2 digits after the decimal point up here, right? We got a 7. We got this guy after the decimal point. We got this guy after the decimal point. So that's 2 digits in total after the decimal. So when we get to the end of our problem, we're just going to plop in a decimal point so that there's 2 digits after it. So if we just work through this problem super quick, 4 times 7 is 28. 4 times 1 is 4, plus 2 is 6. 4 times 2 is 8. And then we've got 7, 1, and 2. So we have an 8 down there. 6 and 7 is 13. 8, 9, 10, and a 3. So I've got this at the bottom here, and I want to figure out where to put my decimal point. So I go back up here and I go, okay, well, I had 2 digits after the decimal point in total up there in the numbers I was multiplying. So I'm just going to plop my decimal point right here so that there's 2 digits after the decimal point in my final answer. And that's all there is to it. So nothing too complicated for multiplying with decimals. Adding fractions, you're exactly right. You have to get the same denominator. So that is, so if we go back to our example of, let's do a different example. Let's change the numbers a little bit. So if we do something like this, so if we've got like 4 over 3 plus 1 over 4, and we want to add those, we need to make sure we have the same denominator at the bottom. So we need to turn both of these into the same number. So how can we do that? The easiest way is to multiply each denominator by the other one. So if we take this first fraction and we multiply the top and the bottom by 4, right? Then what we're going to get is for our first fraction, if we multiply the top and the bottom by 4, we're going to get 16 over 12. And then for our second fraction, we're going to multiply the top and the bottom by 3. So you see, I'm just multiplying both fractions by the denominator of the other fraction, the number on the bottom of the other fraction. And so if we do that for the second fraction, we're going to get 3 over 12. So now we've got two fractions with the same denominator, the same number on the bottom. So now we just add the numerators, add the numbers on the top, and we don't touch the denominator. So we end up with 16 plus 3 is 19 over 12. And then you'd have a final step of, because this number is an improper fraction, you should really be writing it as a mixed number. But that's all there is to that. How are we feeling? What are we thinking? Why does adding fractions always get you to an improper fraction? Well, I mean, yeah, that's just, I mean, in this case, I started off with an improper fraction at the beginning, right? 4 over 3. But normally it's just one of those things that you're going to run into, right? If you start off with a part of a pizza and then you add on another part of a pizza, there's a pretty good chance that you're going to end up with more than a full pizza if you had pretty big pieces to start with, right? If you have 3/4 of a pizza and then you add another 3/4 of the pizza, you're just gonna have 1.5 pizzas. That's just how it goes. Um, can you explain the exponent rules? Absolutely. So there's 4 exponent rules that you need to know for the exam. So the first one is called the product rule. And so that means that if you have two exponents, or if you have two powers, where the bases, the big number here, like the big number in writing, is the same. So like these twos are the same. Uh, and they're being multiplied together. If this big number on the bottom here is the same in both cases, then instead of solving this first one separately and the second one separately, you can combine them into one big power by just adding the exponents. So because we've got a multiplication problem here and the bases are the same, the twos are the same, we can just add 3 plus 4. So this becomes 2 to the exponent 7. And then you can do that multiplication problem. Now, this doesn't actually make things easier so much when it comes to the product rule, because you end up with just a bigger power to calculate. But a more useful one, a lot of the times, is the quotient rule. So the quotient rule is the same idea. You need to have that the big numbers are the same, and your exponents can be different, and you've got a division sign in between. So this time, instead of adding the little exponents to each other, you're going to subtract first one minus the second one. So this one is going to be, you're going to keep the base the same, so it's still going to be a 2, but then your exponent is going to be 5 minus 3. So that's going to be a 2. So that's 2 squared, which is equal to 2 times 2, which is equal to 4. And that saves you a lot of trouble in this second example, because otherwise you would have to sit there and calculate 2 to the power 5, which is 2 times 2 times 2 times 2 times 2. So you got to do that calculation. Then you got to do this other one, 2 times 2 times 2. Then you got to divide that answer by that answer. So 2 to the power 5, 2 times 2 times 2 times 2 times 2 is 32, divided by 2 times 2 times 2, which is 8. 32 divided by 8 is 4. Or you could do it this way, where you don't have to do any huge multiplications, you don't have to do any huge divisions. You don't have to deal with any big numbers at all. Literally, the biggest number that you deal with in this problem is the 5 at the beginning, which is a pretty small number, right? So that's the quotient rule. The next one is the power rule, which is, yeah, I can go back to the triangles after this. So the power rule is if you have a little power in here, a base to some exponent, and then that whole thing is raised to another exponent, you can just multiply the exponents together. So this becomes 3 to the exponent 2 times 3, which is 6. So this one becomes 3 to the exponent 6. So that's what that one is. That's the power rule. And then the last one that you need to know is the 0 rule. So any exponent or any base to the exponent 0, any number to the exponent 0 is equal to 1. Doesn't matter what this number is. If the exponent is a 0, the answer is 1. So those are the exponent rules that you need to know for the exam. So now I'll go back to the triangles. So there's 2 different ways that we can classify triangles. One is by looking at how many equal sides or equal angles we have. And the other one is looking at the types of angles that we have. So I'll show you both of those. So we got the equal sides ones, and we got the types of angles. So for our equal sides, you've got 3 possibilities. You could have that all 3 sides are the same and all 3 angles are the same. And that's called an equilateral triangle. Let me write that in. The second one is isosceles triangles. So these are ones where you've got 2 sides are the same and 2 angles are the same. And then the last one is the scalene triangle, where all 3 sides are different lengths and all 3 angles are different sizes. So that's scalene. And then you've got the way of classifying triangles based on the types of angles. So if you have a right angle in your triangle, then you have a right triangle. If you have an obtuse angle in your triangle, then you have an obtuse triangle. And if you don't have a right angle and you don't have an obtuse angle, then you must have all 3 acute angles. And so you have an acute triangle. Yes, you need to know the names of the types of triangles that we have here. So if there's 6 triangles on here, you need to know what these tell you these names on the exam. So you don't have to memorize them themselves, but you do have to know what each one means because you're going to be given diagrams. Basically, you're going to be given a diagram like that. And I'm going to be like, is this a scalene triangle, an isosceles triangle, or an equilateral triangle? So there's one question where all the diagrams are like that, and I'm asking you scalene, isosceles, and equilateral. And then there are other ones where I give you a diagram like this, and I say, is this an obtuse triangle, a right triangle, or an acute triangle? And you have to know that. And yes, the lines are there. The lines are there so you can tell whether lines are the same size. Do we need equivalent fractions? No, there's nothing on equivalent fractions on the exam. Just addition, subtraction, multiplication, and division of fractions. How are we feeling? Thumbs up for feeling good, thumbs down for terrified, uh, something else for 50-50. Thumbs up, nice. Two variable problems, absolutely. That's probably the hardest thing on the exam. So if you're not comfortable with the two variable problems, you would honestly probably your best bet would be to go back to the lessons on it because I spend a lot more time on them there. But what I can do is I can go through an example here as well for sure. Okay, so let's take something like this. This should work out to nice numbers. So you've been given two equations and you've got two variables. So your first equation is 2x plus 3y equals 18. Your second equation is x plus y equals 7. So your first step is to pick one of the equations and pick one of the variables that you're going to isolate. So I'm going to pick from equation 2, I'm going to pick, let's say, x. I'm going to isolate x. So what I'm going to do is I'm going to get x all by itself on one side of the equation. So to do that, I can subtract y from both sides, and I get x equals 7 minus y, like so. And now that I've got that, I'm going to take that answer and I'm going to sub it into the other equation. So anywhere I see an x, instead of writing x, I'm going to write 7 minus y. So if I rewrite that first equation, then that's going to become, instead of 2x, it's going to be 2 times 7 minus y, like that. And then we just write out the rest of the equation. Plus 3y equals 18, like so. And so now we just have a bunch of y's. We don't have any x's anywhere. So we can solve this like it's a one variable problem. So this brackets at the beginning, 2 times 7 is 14 minus 2 times y. So that's 14 minus 2y. That's that distributive property where you multiply the guy on the outside by every little guy on the inside. So that's how we get the 14 minus 2y. And then we just rewrite the rest of the equation. So plus 3y equals 18, like so. And so now we can solve that. So negative 2y plus 3y, that's just y. So we've got 14 plus y equals 18, right? That's our next step. And then we can subtract 14 from both sides, and we'll get y equals 4. So you go through all of that, you get that y equals 4, and then you can sub that answer back into the other equation. So we have that x is equal to 7 minus y. Now we know what y is, so we can say x is equal to 7 minus 4. So we get x is equal to 3. And so then you've got that x is equal to 3 and y is equal to 4, and you're done. That's your whole answer. Unless it's a word problem, because then if it's a word problem like the whole thing about you're selling the t-shirts and the hats, and I say, oh, well, how many t-shirts and how many hats did you sell? You got to write a sentence at the end that says, okay, so and so, whichever one of you has been mentioned on the exam, sold 13 t-shirts and 25 hats or something, right? So this is the process of how to do the question. If it's a word problem, you got to pull out the equations, and when you get to the end, you got to write out a sentence. But this is the process for how to solve one of those questions, algebra problems with two variables. Do we have any questions about the format of the exam, the types of questions, how many questions, any of that stuff? It's all in the chat, but I know there was a lot of information. So if anybody's confused about how many questions, how many marks, total marks, I can give you that. Total marks on the exam. If I've done my addition right, 86. So it's going to be marked out of 86. Will I do another one? Another what? Another two variable problem? Yes. Okay. Yeah, for sure. Yeah, it is a bit of a long exam. So if I make that. Okay, so here's our next one. So we've got first equation, 3x minus 2y equals 0. Second equation, x plus y equals 20. So you could isolate wherever you like. I'm again going to pick this equation just because the x and y don't have any numbers attached to them. So I think those are easier to isolate. This time, let's isolate the y. So I can do that by subtracting x from both sides, and I'm going to get y is equal to 20 minus x, like so. Y equals 20 minus x. Now I plug that into the other equation. So wherever I see a y, I'm going to write 20 minus x instead. So we get 3x minus 2 times 20 minus x equals 0. Okay, now we got to do the distributive property. So the first thing, we're going to have the 3x there just by itself. We're not touching that. And then when you have a minus sign in front, it's a little bit tricky when you do the distributive property because you got to switch the signs on the inside. And the reason for that is that we do this distributive property thing as though this isn't a 2, but a negative 2, like a minus 2 being multiplied by those things. So negative 2 times 20 is negative 40. So we write minus 40 down here. And then negative 2 times negative x is going to be positive 2x. So we put plus 2x is equal to 0. So it's a little tricky if you've got negative numbers. So for a question like this, if you see that you've got, oh, I've got that minus sign in front of the 2y there, maybe you isolate x on the other side instead of isolating y. So you do have that choice. I just didn't think it through before I chose to isolate the y. But now, once we get to this stage, we've got 3x and a 2x, and we don't have any y's anywhere. So this is a one variable problem. So 3x plus 2x, that's 5x minus 40 equals 0. Are there negatives in the exam? Yes, there are quite a few negative numbers in the exam. But they're not complicated if you know how to multiply negative numbers by negative numbers becomes positive numbers. That's all you need. So we've got 5x minus 40 equals 0. So we get 5x is equal to 40. So we get x is equal to 8. And then now that we have that answer, we can sub that back in to the other equation where we said that y is equal to 20 minus x. So we get y is equal to 20 minus, and then we had x is equal to 8. So y is equal to 20 minus 8. And we get y is equal to 12. So, my biggest tip for two variable problems, you might not like the tip. Take your time. Don't rush through the problem because when you have the two variable questions, it's really easy to confuse yourself about what step I'm doing. If you've got this like negative number nonsense that we just went through with this question, you're going to make a mistake with the signs. If you rush through it, you're going to make a mistake with the signs. So take the questions with negative numbers slowly, especially if it's the algebra problems, especially if it's the two variable algebra problems. Let me see actually what those ones look like in the exam because I've got the exam right here. So there's a little bit of stuff going on with the negative numbers when it's just with one variable. There's a little bit with the two variable questions as well. So yeah, there is a little bit of stuff with the negatives. Not too much, and not in every question, of course. But there are a couple of questions where that's basically the easiest way sometimes for me to make a question harder. Is I give you one where you've got a whole bunch of plus signs, and then I give you another question where it's about as difficult, but I throw in some minus signs, and that's just what makes the question harder. So when you've got like a part A, part B, part C, and I want them to get harder as you go through, part A, no minus signs. Part B, a minus sign. Part C, all minus signs. That's an easy way to make questions harder. So that's why there are a few minus signs in certain parts of the exam. But overall, there aren't a ton, I'd say, but there definitely are a few. And I can even tell you the ones where you'll see that it's in the algebra problems that aren't word problems, the algebra problems that are just here's your equation, solve the variables. So it's in questions 5 and 6. So brace yourselves for questions 5 and 6. I'm sure you guys will be fine. I'm sure you guys will be just fine. How are we feeling? For everything that's not algebra. Yeah. Yeah, the algebra problems, the one variable and two variable algebra problems are a little bit tricky. If you guys want, I can give you how many marks each sort of topic is. So, like I told you before, it's like, oh, question one is fractions, question three is decimals, whatever. I can tell you how many marks each question is so that you kind of know where the focus of the marks are. So, so question one, which was fractions, is 16 marks. Question two, which is improper and mixed fractions, 4 marks. Question three, decimals, 16 marks. Question four, exponent rules, 8 marks. Question five, algebra with one variable, 8 marks. Question six, algebra with two variables, 6 marks. Question seven, which is classifying triangles, 4 marks. Question eight, which is also classifying triangles, but the other way. So instead of equilateral isosceles scaling, that's question seven. Question eight is acute, right, and obtuse, the other way that we can classify triangles. That's also 4 marks. Question nine, which is classifying quadrilaterals, is 8 marks. Question 10, which is a word problem on percentages, 3 marks. Question 11, which is a word problem on perimeter and area, 4 marks. And question 12, which is a word problem that's algebra problem with 2 variables, 5 marks. Can I do subtraction of fractions? So yeah, so subtraction of fractions is just like addition of fractions in that you have to get a common denominator. And what do you mean by improper fractions? Like converting them to mixed numbers? Yes. Okay, cool. Yeah, let me show you both of those things. So first one is subtracting fractions. So suppose we have something like this. So we've got 5/6 minus 1/2. So we need to get the denominators to be the same. Now I could multiply 6 times 2 and 2 times 6, or I could realize that if I just multiply this guy by 3, it's going to become a 6. So what I'm going to do is I'm going to do that first. So I'm going to do 2 times 3, and whatever I do to the bottom, I have to do to the top. So we're going to get that the first fraction doesn't change at all, so it's still 5/6. And the second fraction, 1/2 becomes 3/6 because we multiplied the top and the bottom by 3. And so now that we've got the same denominator, we don't have to touch it anymore. We just have to do the subtraction of the top numbers. So 5 minus 3 is equal to 2 with a 6 in the denominator. And then we just have to reduce that down because both the top and the bottom can be divided by 2. So we get 2/6. If you divide the top by 2, you get 1. And if you divide the bottom by 2, you get 3. And so you get an answer of 1/3. So there's your subtraction of fractions. So the next thing in the requests is converting an improper fraction to a mixed number. So basically, you just have to ask yourself, how many times does this go into that? So how many times does 6 go into 19? Well, if we start counting 6, 12, 18, 24. Okay, 18 is the biggest multiple of 6 that fits inside 19. And this is 6 times 3, right? So we can get, if we had 19 slices of pizza and each slice was 1/6 of the pizza, we can make 3 whole pizzas because that's 18 slices. And then we have 1 slice left over. So going from an improper fraction to a mixed number, you're basically just doing division. You're basically just doing 19 divided by 6 that way. How many times does 6 go into 19? 3, with a remainder of 1. And that 1 is this guy right here. Now, for a word problem, for an algebra word problem with 2 variables, that's not something I can do like on the whiteboard because it's just I don't have enough space on it here. So what you can do, just because the word problem itself takes up so much space to write out, because the word problem will say something like, I want to buy popcorn and a drink at the movie theater, and the popcorn costs this much and the drink costs that much, and if I have to pay this much in total to buy popcorn and drinks for me and my friends, then how many bags of popcorn did I get? How many drinks did I get? There's so many words that go into it that you have to pull the equations out of. So you would probably have better luck um, with lesson 18. Lesson 18 in our on the YouTube channel is called Word Problems with Two Variables. Lesson 18, Word Problems with Two Variables. All right, so check that out for some word problems with two variables, because that's what you're looking for. The word problem for perimeter and area, don't really worry, don't think about it too much like it's a word problem. Basically, I'm telling you without the diagram that I'm about to draw, but basically all the wording in the question is saying, hey, you got to figure out the area or the perimeter and the area of the basketball court, the school's basketball court. And instead of me sending you outside to measure it, I'm telling you, okay, suppose this side is 25 meters and suppose this side is 18 meters. Go. Figure it out. Figure out the perimeter and the area. And actually, I haven't given you the actual numbers from the test, but they're not bigger than this. They're smaller than this, the numbers that I've given you. So nothing too complicated. The only challenge is that I haven't actually given you this diagram. Everything is in words. Could you do an example of a one variable problem? Absolutely. So a one variable problem would be something like this. So you've got one letter that shows up throughout your thing. You could have multiple x's. Like I could have had like 32 minus x. This is still a one variable problem because it's only x's. There's no y, there's no z, there's no w, right? But this is your one variable problem. And we just need to get the x by itself. And that's all there is to it. So we'll start this by adding 16 to both sides so that we get rid of this guy right here. So we get 24x is equal to 32 plus 16, which is 48. And then now I don't want 24x, I want x. So I'm going to divide by 24, divide by 24. I'm left with x on the left side, and 48 divided by 24 is 2 on the right side. No problem. So I will say for you guys, I'm happy are if you learn a lot more from these live review sessions, I'm happy to stick around and do a couple more examples. But if you don't want my rushed explanation right now of like coming up with a question in 15 seconds and going through it in 2.5 minutes, if there's um, if there's a topic that's like, oh shoot, I wish I could, see another example of, dividing decimals or something, go to the lesson for it. Go to the lesson on the channel on dividing decimals because I'll take 10 minutes to go through that question instead of two. And I'm going to walk you through every single step and emphasize the key points. Of course, if you have more questions that you'd like me to answer here, I can stick around and do that. But if there's a specific topic that I really struggle with dividing fractions, go to the lesson for dividing fractions instead of this, because I would do a much better job of explaining it in the actual lesson. There's not going to be anything on equivalent fractions on the exam. Are you allowed to explain something about math, even if it's not something you teach us? Absolutely. What's the question? How do you get the area of a circle? That's a great question. So there's actually a very easy formula for it. Um, Now, how mathematicians come up with these formulas is not uh, something that we could discuss in just a couple of minutes because the way they do it takes a little bit more time, a little bit more energy, a little bit more thought, and it's something that's not going to be on your exam tomorrow. Um, but maybe something for the future. But the formula for the area of a circle is this. So you've got a circle that's got a radius r. So the radius is the distance from the center to any point on the outside because all the points on a circle are equally far away from the center. So the radius is the distance basically halfway across the circle. And the formula for the area is you take that radius, you square it. So you multiply it by itself, right? That's like r times r. And then you multiply it by pi, which is that fancy special number that goes on forever and it doesn't repeat. And it's something like 3.1415926.5, etc. 19265 358,959, something, it goes on forever. It's been a while since I practiced it. It's been a long day. Um, on a good day, I can still reel off about fifty decimals of pi, but today is not one of those days. But yeah, that's your formula for area of a circle. So you take pi, you multiply it by r, and you multiply by r again, and that gives you the area of a circle. And that's something actually that we would have gotten into in our geometry unit if we had more time. I know that your guys' school year ends earlier than school years tend to here. But I thought that there probably would have been like another week or so, just because a few years ago when I was teaching in this like YouTube setting, the last test review that I did was on May 28th, and like school was ending in like that first couple days of June. So I thought I had another week that we could get through some other cool stuff. The perimeter of a circle has a special name that's called the circumference. Spelled like that, circumference. And the circumference of an area, so we already said the area is pi r squared. The circumference of a circle is 2 pi r. 2 multiplied by pi multiplied by the radius. Or if you prefer, instead of the radius, you could talk about the diameter, which is the distance all the way across the circle from one end to the other. And so the circumference can also be written as pi times the diameter, pi d. No problem. How are we feeling? All set or about as ready as we're going to feel before maybe a little bit more review tonight? The volume of a cylinder or the volume of a cube? Okay, so for a cube, it's very straightforward. I'll show you both. So for a cube with a side length x, the volume is just x cubed. So whatever the side length of your cube is, you multiply it by itself, and you multiply it by itself again. So it's x times x, whatever your side length is. And for a cube, or so not for a cube, for a cylinder, so you've got a radius of the circular base, and you've got some height to the cylinder as well. So basically, for the volume of a cylinder, you figure out the area of the base. So that's pi r squared, because that's the area of a circle. And then you just multiply it by the height of the cylinder. So it's pi r squared h. And that's all there is to it. That's simple. Any other questions, or are we feeling pretty good for tomorrow? No, you're gonna be fine for tomorrow. So, if you do have a little bit more time before bed, if there are one or two concepts that you're still struggling with, check out the other lessons. Check out the lessons from this course, and if that's not helping you, uh, I might actually also have some of the same topics, not all the same topics, but some of the same topics were covered in my course called Flamingos Math 2019-20. And that's a 63 video playlist. So there's some stuff in there on algebra and on fractions and things like that. I talk about in that course as well. I don't think I ever did a geometry unit there, but yeah. Oh, well, I'm glad you're better than you were before. Yeah, take a deep breath before you start the exam tomorrow, because it's when we're stressed that we make mistakes. So try and take it easy, try and relax. I know it's a stressful time of year and you guys have like a million things going on tomorrow, but you guys are going to do great. You got this. Awesome. Yeah, and that's the thing, right? Is that it's hard to get perfect on these exams. I used to make mistakes on my math exams as well. Sometimes it was as easy as addition mistakes. Once I almost got perfect on a math exam, and the only mistake I made was I said that 45 plus 40 was 95, not 85. It happens sometimes, you know? Don't stress out if you lose marks here and there. The important thing is that you understand, generally speaking, what's going on, what's happening in the math, why am I learning this math, when is it going to be useful. Those are a lot more important than whether you got this exact question, this exact word problem about calculating a tax correct. If you understand the idea of how it works, but you made a multiplication error, you got a little confused because you were stressed, that happens. I'll hang around for a couple minutes in case anybody has any last minute questions. But if the chat is quiet for another few minutes, then I will assume that you guys are as ready as you're ever going to be, or you're going to go study a different video or something. But yeah, I'll hang around for a couple more minutes. And if the chat stays quiet, then we'll call it a night. All right, awesome. I'm not actually sure you're gonna see me again because if you guys have a bunch of like non-school stuff going on in the next few days, then you won't see me again this school year. But hopefully in September. Yes. Good luck with your history and your French, and good luck with the math exam tomorrow as well. And I will hopefully see you guys in the fall. You're welcome. Good luck. All right. So since I'm not seeing any more questions here, I'll wait another like minute just in case there's an absolute emergency. But other than that, I will take the silence in the chat to mean that you guys are as ready as you're going to be from this review session. I am still available on Instagram if you are doing some late night studying, which you really shouldn't be doing because a good night's sleep is important. But if you are doing some late night studying and in an hour you realize I don't understand anything about dividing fractions, send me an Instagram message, and I'll be happy to help out. So I'll be up for a little bit for sure. I'm not sure I'll be necessarily checking the YouTube comments. So if you can get in touch on Instagram or WhatsApp, that would be the way to do it in an emergency. But I can try to check the YouTube comments in like an hour or so. Uh, but in case I forget or I'm not able to do that, if you have an emergency, shoot me a message in a more direct way or have one of your parents do that. And yeah, good luck tomorrow. And I'll see you in September, hopefully.